Okay, so for question 2, you're given the following truth table, or the output is 10100110. What is the Boolean function representing this truth table? Did you find this easy or difficult? Try doing in reverse, starting with the input Z. That's just a hint. So, as you can see here, what we've seen so far is you've been given the function, you draw the truth table for F, for G, and then for H in this case, and then from there you go into a decision tree or decision diagram. But let's say you're given the truth table and you want to know what Boolean function it is. How can you work backwards from the truth table? And for this question we're going to use disjunctive normal form. You could also use conjunctive normal form, and let's go through exactly what they are. So disjunctive normal form is AND clauses. This is a clause. So AND clauses connected by disjunctions. So X and Y clause, Y and Z clause, and they're joined by an OR. So if either of these is true, then the statement is true. The function is true. For conjunctive normal form, it is disjunctive clauses. So X or Y, Y or Z, connected by conjunctions. So if this clause is false, then it's all false. So that's the reason you do these. So disjunctive form, if any clause is true, then it's all true. Conjunctive normal form, if any clause is false, it's all false. Because anything in false is false. Anything or true is true. So here's our truth table here on the left. X, Y, Z, 0001, 10001. So how would we start this type of question? And I've given you a hint here. Try doing your reverse. Start with the input Z. So what we actually do is you want to divide this table in half. So you want to start with where X is all of zeros. So we're going to take the first 4 bits first, get the clauses to get 1010, and then we'll take the second 4 bits to see how we get 0110. So let's start with the first 4. Well, let's start with our first bit, Z. So when we have 1 bit, when we have Z, 0 and 1, our output is 1, 0. So you can see in this little box. So when Z is 0, output's 1, Z is 1, output is 0. So we can actually tell that Z is false. So it's not of Z. So when Z is false, we get true. When Z is true, we get false. So it's not of Z in this 4 bits. And it's the same here. Now, of course, that's only for the first 2 bits. In fact, let me get my ruler once more. Move it. So this is what we're focusing on. We're focusing on the first 2 bits where Z is 0 and Z is 1. we get 1, 0, so it's going to be not of z. Now, what combination of 0, 0, 0 will get us 1, and 0, 0, 1 will get us 0? So let's take the y value. So y, z. So we have 0, 0, and 0, 1. Getting us 1, 0. So, what values of y and 0, or y and not z, get us 1, 0? So if y is 0, not z is 0, we get 1. So that'd be 0, 1 gets us 1. So when y is 0 and not z is 1, we get 0. So you can think of this as 0 and 0 gets 0. But we have to use disjunctive normal form. So it has to be y and not of z. Or it has to be not of y and not of z. These are our two options for getting 1 and 0. So y and not of z. 0 and 0 gets 1. So it would be 0, not of z would be 1, gets 1. So that can't happen. 0 and 1 can't get you 1. So that rules this out. Right, let's just make this clear to see what I mean. So let's actually do not of z here. Not of z, so that would be 1 and that would be 0. So 0 and 1 gets 1. So that's not true. So we can't use y and not z. So not z and z. So 1 and 1 gets us 1. That is true. But when y is not, so that's going to be 1, 1, and 0 gets 0. So we can do that. And conversely, if we add in x, y, z, or not of z, again focusing only on the first two bits, x is 0, y is 0, not of z is 1, 0, it's actually going to be exactly the same. It's going to be not of x, and not of y, and not of z. Because if x is 0, not of x is 1, not of y is 1, 1, 1, and 1, and 1 gets us 1. And 1, 1, 0 gets us 0. This is also true for our first two bits. Which also means not of x and not of z is also true. So we can have these three different clauses for the first two bits. Now we don't need these three clauses, so we're going to see which one do you pick. Do you pick not y and not z, not x and not y and not z, or not x and not z? Well, we're going to see that depending on our next two bits, when we take it as 4 bits, which ones we're going to actually take. So it's going to be this, or another clause will get us 1, 0, 1, 0. So let's take the next 2 bits. So we've finished with here, and we're now moving on to this section. So once more, zoom out. We'll get rid of this. Lasso that over there. Okay. So now let's take the next. Zoom in a bit once more. The next 2 bits, 0, 1, 0. So again, we start off with our 1 bit. So Z. 0, 1. Output is 1, 0. So it once more is not of Z. So let's take Y and not of Z. So Y is 1, not of Z, so Z is 0, 1, not of Z is 1, 0. Output once more is 1, 0. So we can tell already Y and not Z gets us 1, which is true. Y and not Z gets us 0. So we have Y and not of Z. In the second half gets us 0. So this is true. And let's do the last one. Let's do X, Y, Z. X, Y, Z. So 0, 1, 0. Apologies. We're doing not of Z, aren't we? So Z is 0, not of Z is 1. 1 and 0. So we can have not of X and Y and not 0, or not of X and Y and not Z. So that will be 1, 1, 1. Output is 1, output is 0. That will get us 1, that will get us 0. So this is also valid. It will be not of X and Y and not of Z. Now, let's take the first 4 bits, 1, 0, 1, 0. 1, 0, 1, 0. To get the first 1, 0, we had these 3 clauses. That was for the first 1 and 0. I'll move them up just a bit here. And for the second 1 and 0, we had these 2 clauses. So you have these 5 clauses for 1, 0, 1, 0. The top 3 are for 1, 0, is 1, 0. Bottom 2, this one's 0. So what ones do we actually need? We don't need all 5. to just get 2 sets of outputs. So we have y and not z. We also have y and z. So we have x, not y, and not z. And again we have not x and y and not z. So clearly we can't have a not y and z and a y and not z. So in 4 bits y can't be true and false. But if you see here, y and z gets you the same value, but not y and not z gets you the same value, but not x and not y also gets you the same value. And we can see in the second set that not x and not y is also true. So not x and not y is throughout all clauses. But y and not, so y and not a y clash. What we say here is, since not of y and not of z is true, gets 1, 0, and not of x and not of z is true and gets 1, 0, we don't actually need this y, not z. We can get rid of these two. This allows us to have y is true and x is false. Once more, we don't actually need this long drawn out value, because just to see why you don't need not of x and not of y not of z, because y and not z is true, you don't need not of x and y and not z. It's just a longer version of this formula. So we can actually cancel this. And what we have here is not of x and not of z, y and not of z. And what we do then is we join them by a disjunction. And that will get us 1, 0, 1, 0, our first 4 bits. So to go through this again, we had not of y and not of z on the top half for 1, 0, and we had y is true on the bottom half. However, we saw, so we can't have y is false and y is true for the same 4 bits. So what we do is we see that not of x and not of y is on the bottom and the top, and this gives us the same values of not of y and not of z. So we can cancel out not y, not z, and all the formulas where that is true. Keep not x, not of z, which is valid for the first half, is valid for the second half. And we'll keep y as true. And we'll remove this longer version, as we have a shorter formula here, and leaves us with our 2 clauses. Not x, not y, y and not z. That gives us our first 2 clauses. So we don't So 1010 has been taken care of with these 2 clauses. And you can check it. You can check the values as well. So we can now check this value. So not x and not of z. So x is 0 and z is 0. You get 1. So 1 and 1 is 1. Not x and not of y. 1 and 0 gets 0. That's true. or y and not z. So when y is true, not z is 1. 1 and 1 is 1. 1 and 0 gets 0. Now you may be thinking, as we saw the value here, there was not of x and y and not of z. You could think that you have a not of x, you have a y, and not of z, so why not use this joint term? But if you can see, if you have not of x, so that these would all be 1, and y, so 1 and 0, that's 1, that would immediately be false. So you cannot use this term for the whole 4 bits. So you can get rid of that, you can get rid of this, get rid of this. That leaves us with our first 2 clauses. And for the next section, you got to move on and do the next 4 bits. So let's do the next 4 bits. So we'll work on this section now. Now, this section is actually easier. So again, we start off with z, 0, 0, and 1. And our output is 0 and 1. So it's just z is z. That's true. Incorporate y and z. Again, we're just doing the first 2 bits. So 0, 0, 0, 1. Output is 0 and 1. Then we can tell that y and z is not going to work. So y and z as 0 and 1 does not equal 1. But not y and z will work. So not y, 1 and 0 is 0, 1 and 1 is 1. Let's throw in our last value. And as you can see, you get quicker at this as you go along. 0, 1, 0, 0. And we know already it's not going to be not y, and 1 is 1. So x is always true. So if y and z gives us 0, 1, well, x is already 1, so x and not of y and z. So 1 and 1 and 0 is 0. Sorry, sometimes we click and it doesn't register. So 1 and 1 and 0 is 0. 1 and 1 and 1 is 1. This is also true. Now, which of these 2 clauses will you need? Well, let's do the next 2 bits. So z once more. Is, so our outputs are 0, 1, and the result is 1, 0. So we know from earlier that this is not of z. So if you're wondering where we are, we're working on the second 2 bits here. So y and z going to be not of z. So 0, 0, 1, 0. apologies, actually 1, 1, 1, 0 gets us 1, 0. So again, this is y and not z. And if we throw our x in, x, y, z, not of z, well, x is always 1, so 1, 1, 1, and then 1, 0 for our not of z. Our output's going to be 1, 0. Then it's going to be x and y and not z. Now we already have a shorthand version of x and y and not z, so we don't actually, while this is correct, we don't need it, because we already have a shorter version, y and z. But, as we saw earlier, we already, in our first two bits, we have not y and z. Also, we already have a y and not z in our earlier two clauses. So we don't actually need the second part of this to get 1, 0. We've already got 1, 0 earlier with y and not z. So this is actually not needed, because we already have y and not z in our clauses, so we can actually remove all of this. Just to go through that once more. We get y and z, we get x and y and not z. We don't need x and y not z because this y and not z up here is already true. Already gets us 1 and 0 for the output. So we don't need this. For y and not z, in our earlier clauses, we have a not y and z. So we have a conflict there. But also, in our earlier work, we already have a clause called y and not z, which gives us 1 and 0. So this will actually work both in the second section and the fourth section. So for these two bits and these two bits, it'll give us the desired output. So we do not need this. Now, our next question is, which of these two clauses for the middle third, so this 0 and 1, so our output is 0, 1 here, which clauses do we want? First of all, y and not z does not work, so we don't want that. So do we want y, not y and z, or x and not y and z? Well, we already have a clause called y and not z. So, do we want the clause that is the exact, which is the opposite of y, called not y and z? So not y and z, or y and z. So they are opposites. So what we actually need is we need the x value. So we need x and not y and z. So we need the x value to separate it from this y and not z clause. So we add in our final 0, 1, 0. Apologies, that's not right. 0, 1, 1. Our final answer is x and y and z. So it's not x and not of z. We'll get us the first 1 and 0. Or y and not z, which will get us this 1 and 0. And will also get us the final 1 and 0. It works actually in two areas. Or x and not y and z, which will get us this middle area, where it's 1, 0, 0 to get 0, and 1 not of y would be 1, and z is 1, and get us 1. So this would actually get us 1, 0, 1, 0, 0, 1, 1, 0. I realize this is tricky and it takes a bit of getting used to, but just try it and see how you get on. You can try it with different functions and see how you get on. But it's better to build up clause by clause and then rule out clauses you do not need, or rule out based on conflicts such as positive and negative variables across 4 bits. But if your overall goal is simply to just get the output, get a combination of clauses that simply gives you your desired outputs. And if you find a clause that can give you desired output in multiple areas, that's even better, such as y and not of z. And look out for conflicting clauses such as y and not z, and then having or not y and z. And just choose which one is more desirable. And sometimes you need an additional variable to differentiate between the clauses. And that is it for question 2, which is one of the more difficult questions you will actually get. It actually looks like a simple question. You'd think it would be easy going backwards, but it's actually quite difficult.